6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8.
All right, ladies and gentlemen, so now that you've had a chance to see some students and some animations of the walking of these tracks, let's take a look at it and start analyzing that data. So the first thing you'll see when you open up your document is this big thing here, this first page, and what you really see are those two tracks. And so if you see it on the document, they're up and down. I have a little example here of what it actually looked like in the hallway where we had 0 through 8. And if you'd like, at home, you can set this up and try to walk through it yourself. The measurements are given in the data table on the second page. It really is useful to feel those changes as you're moving, but you don't have to. You can just use the video to help you out. What we did is we walked the length of the long track and the short track, going to each number as it was called out. So each walk took a total of 8 seconds, but you moved a different amount of space. What you're going to do is the distance from the start to 0 is recorded in the data tables. You'll fill in the data tables on the next page with some analysis here. So we'll work on that piece of it together. The second page of your document looks like this, and what we're going to do now is we're going to walk through part of these calculations together. The first thing I want to point out, we're going to zoom in a little bit here. The first thing I want to point out is that we're not going to use this resource for graphing. The other one that we used was a better tool for this activity. So you can type this in, or it should be linked either in the posts or in the assignment itself, depending on which teacher you have, how it was adjusted. So we'll walk through, we're going to create the graph first, because our graph is going to compare our position and our time for track 1. So we're going to look at this long track, and we have our position and we have our time. So let's see what that looks like. Well, if I open up this digital graphing tool, I need to type in all of my information from that document. My title of the graph is going to be long track. That's the first one I'm focusing on. My horizontal label, so I'm measuring I'm measuring time in seconds on my x-axis. And my vertical label is going to be the distance in meters. My horizontal data type, well, that's going to be the number of seconds. So that was the counting out that Ms. Thomas or I, the 0, 1, 2, 3, 4, 5, 6, 7, 8. We want that to be on our x-axis, and you'll see in your column on your data table, it's that first column. We only have one line on this graph here. And then our line 1 data values, well, those need to be our vertical data values, which in this case, that's our position. So at 0 seconds, we were at the 0 mark. At 1 second, we were at 0.25 meters. And so you'll go through and type in each of those values with a space between it in the box. I changed my color to purple because I was feeling like purple was a fun color, but you don't have to. Then when you hit draw, you should get a graph that looks like this. And this should stand out to you. There's some interesting things happening here. This is not a straight line. Depending on what math class you're in, you may or may not have been introduced to nonlinear functions yet, but this one is an example of a nonlinear. It's not a line, it's a curved line. So let's keep going now. We have our graph, so we need to insert it into our document, and you can do that by dragging and dropping or copying and pasting, whatever works for you. But you want to get it inserted into the document. I'm back on that second page now with the long track, and I'm going to put my graph into the spot where it goes, however you can do that. For some students, when they were trying this activity with the dragging and dropping, it was dropping it into like a random spot in the data table, and that's okay. Just leave it there, and then you can drag it over again and make it big enough so that I can see what your graph looks like. Now, before we analyze this data, the first thing I want to do is I want to go over some vocabulary. There's some important things to talk about here with all of these different numbers and letters and all sorts of stuff going on. Let's talk about each of these pieces. Now, the first piece is pretty straightforward. T is for time. We're measuring our time in seconds. So that entire first column is our seconds. The next column is our position. We're measuring it in meters. So we have a position of 0 at 0 seconds, and then 0.25 meters, so a distance of 25 centimeters. Then 1 meter, then 2 meters and 25 centimeters, all the way through. Ms. Thomas and I set up this in the hallway if we were at school. And at home, you can set this up on your own, or you can rely on the video. The next piece, and you see this triangle pop up a few times, that triangle is the math or physics letter delta, and it means change. So delta x in this case tells us our change in position. So the amount our distance changed between the first marker and the second marker, and then the second and the third, and then the third and the fourth. Well, the next one, delta t, that tells us change in time. So how much time passed between those two markers. The next piece is velocity, and we know that velocity is speed in a given direction. We need to have both pieces. In this case, our direction was the same throughout the entire pathway. We were only moving forwards or away from our reference point. But we can calculate the speed by taking distance divided by time. The next column asks us to find the change in velocity. So how much did our velocity change between each marker? Which leads us to the big idea of acceleration lab number 1, which is acceleration. For an object to be accelerating, there are 3 different situations that could happen. We could be increasing in speed, we could be changing direction, or we could be decreasing in speed. And in this case here, you can see that we are increasing in speed, so we are experiencing acceleration. To calculate that, we're going to use the idea of the change in velocity divided by the change in time. That came from your reading that you completed earlier this week or last week. So now that we've talked about each of these different terms that we're going to find, let's go through some of the calculations together. In my document here, I'm going to just leave those here's my graph, but I'm going to leave those vocab terms next to me just so that we know what we're talking about as we fill this in. The first thing I want to do is that first column, there's no change. It's zeros the whole way across. So I'm just going to put dashes, and on your screen you can type in a dash so that we know there's nothing we really need to fill in. We could type in zeros into this box. But now let's think about our change in position between 0 and 1. So to calculate my change, that tells me the difference, and I take my distance at the first marker minus my distance at the 0 marker. So 0.25 minus 0 gives me 0.25. So my change in position for this first box is 0.25. My change in position for the next one, if I go 1 minus 0.25, well, that's a change of 0.75. From 2.25 to 1, well, that was a change of 1.25. From 2.25 to 4, that was a change of 1.75. Pause the video now and you can fill in the rest of that column on your own. When you're ready, now let's talk about change in time. Well, as I go from 0 to 1, how much time changed? Well, 1 second. From 1 to 2, how much time? Well, again, that's 1 second that has passed. 2 to 3, 1 second has passed. 3 to 4, 1 second has passed. Pause the video now, fill in the rest of the table. Now let's talk about our velocity and how we can calculate velocity at each point. Well, I know that velocity is going to tell me distance divided by time. So the distance that I traveled in this first one here, let me get another color. My distance was 0.25, and I traveled that distance in 1 second. So 0.25 over 1 is going to give me 0.25 again. Now I'm going to do the same thing to calculate my instantaneous velocity at the next one. I take the amount of distance that I traveled divided by the amount of time that it took me. And again, 0.75 divided by 1 is 0.75 meters per second. On the next one, same thing. I traveled 1.25 meters in 1 second, which is a velocity of 1.25 meters per second away from my reference point. Then I traveled 1.75 meters in 1 second. 1.75 divided by 1 is 1.75. Pause the video, fill in the rest of that column. Now I want to find the change in velocity. Just like when I found change in time or change in position, I need to look at my two pieces here. Because this one doesn't have any piece below it, I can put dashes again. From marker 1 to marker 2, my change in velocity is 0.5. If I take 0.75 minus 0.25, I get 0.75. 1.25, take away 0.75, well again, I have a change here of 0.5. 1.75 minus 1.25 is a change of 0.5. Fill in the rest of the table using your numbers from before. And now let's think about our final piece here. We're talking about acceleration. Acceleration is that change in velocity compared to our change in time. A change in velocity of 0.5 divided by a change in time of 1 gives me an acceleration of 0.5. My next piece here, again, change in velocity of 0.5 divided by a change in time of 0.5. Change in velocity of 0.5 divided by 1 for my change in time. Fill in the rest of the table, and you should notice patterns here. You should be able to tell me something about the velocity and the change in velocity, which is our acceleration. Make sure you have this chart completely filled in, and then we're going to move on and we're going to talk about the short track. Same vocab words as before, but what I want to do is I want to create that line graph comparing my position and time using this rapid tables tool instead of the NCES one. So head to that resource again, and you're going to type in the information from your position and time. Same things that we talked about before. When you type it in, it should look like this. This time we're talking about the short track. So when you open it up, it might have all your info from the long track filled in still. You can just type over it, type short track. Time is still the same. Distance in meters is the same. Still talking about data values. Our data values, again, are 0 through 8. We're measuring time in seconds, and we measured it each second. And the other piece that's different is this line 1 data values. This time you're going to type in the distances for each flag or each marker on our pathway, and then hit draw. This time I changed it to a nice teal. When I hit draw, my graph looks like this. I have a nice straight line. It looks more like what we talked about before, where I have time and distance are changing at a constant rate. So now if I jump back to my document, I can drag and drop, copy, paste, however you want. We're going to move that graph into the correct spot. And then we're going to do some calculations. We know what each of these pieces mean, so I'm going to do some of it with you, and then again, like before, you're going to have to calculate some of it on your own. Let's do green this time. Again, that first box doesn't really have anything to fill in. I can fill in dashes or zeros. My delta x, well, delta x tells me change in position. My change in position from 0 to 0.5 is 0.5. My change in position from 0.5 to 1 is 0.5. My change in position from 1 to 1.5 is 0.5. My change in position from 1.5 to 2 is 0.5. You should notice a pattern, fill in the rest of that column. And then let's talk about our change in time. Well, change in time, now we're talking about our change in these values here. From 0 to 1 is a change of 1. 1 to 2 is a change of 1. The pen wasn't working. There we go. 2 to 3. 3 to 4. Fill in the table with the rest of the information here for change in time. My next column talks about velocity, and again, velocity is speed in a given direction, and in this case, our given direction is away from the reference point. To calculate speed, I take distance divided by time. So I have a distance of 0.5 divided by a time of 1. My instantaneous velocity at the first marker is 0.5 meters per second. My instantaneous velocity at the second marker, I take 0.5 divided by 1 and I get 0.5. My instantaneous velocity at the third marker, again, I take 0.5 divided by 1 and I find an instantaneous velocity of 0.5. Last one that I'll do with you, and then the rest is on your own. 0.5 divided by 1 is again an instantaneous velocity of 0.5 meters per second. Like before, we can cross off these two boxes, or you can put zeros in. We're going to talk about now the change in velocity. Again, delta means change. The change in velocity asks me to find the difference between my velocity at marker number 2 and my velocity at marker number 1. Well, 0.5 take away 0.5 is a change of 0. Between marker 2 and marker 3, I was going 0.5. I'm still going 0.5. That's a change of 0. Between 3 and 4, well, if I take 0.5 minus 0.5, I find that I have a change of 0. Fill in the rest of the table. And now, let's talk about acceleration. Like before, I know that acceleration is my change in velocity compared to my change in time. And for my first box here, let's switch to purple. I like purple. Well, let's do red. I haven't done red yet. For my first box here, I'm just going to do it down here so we've got a little bit more space. My change in velocity was 0. My change in time was 1. Now, those of you with strong math skills should be able to recognize that 0 divided by something is 0. It's not undefined. I can do it. I can't have 0 on the bottom of my fraction, but I can have 0 on the top. So my acceleration in this case is 0. Again, I'll do the same thing for my marker number 3. My change in velocity was 0. My time was 1. So I have 0 acceleration. 0 over 1, 0 acceleration. By now you should have noticed a pattern, and you should have been able to feel that or notice that when you watched the students walk this track. They are moving at a constant velocity, and if I'm moving at a constant velocity, I am not accelerating. So now your job is to finish, after you finish these tables, is to take all those big ideas and go back to that first page. You've got some analysis questions to answer with complete sentences, where you're talking about these different pieces that we just figured out and the data that we collected. Get this finished up and then submit your assignment on Teams when you're done.